Good day, everybody, and we are back again together. All right, so today I want to just make sure that I help you out in Newton's laws, Newton's second law applications in particular. So please, if you haven't subscribed, please make sure that you subscribe. I know that you guys are working really hard to try and get those exams going, and I've been appreciating quite a lot of feedback that you guys are giving me in terms of how well you are doing in your exams. That's the very purpose why we created this platform, to try and help you out as much as we possibly can. And by the way, I do appreciate all of those comments, that are coming in and flooding in very fast. Okay. And by the way, if you haven't subscribed, please make sure that you're part of this family. Okay. Yeah, we want you to be a part and enjoy every notification. Just hit that bell button as well. Um, yeah, so let's get going. By the way, for those of you who need help with tutoring, you are more than welcome to send me an email. That's info@mlungisinkosi.co.za. Okay, you are welcome to just send me that email there. All right, now I took this question. Now I'm not going to put the question paper of it, but I'm going to take you through the question as I answer it. Okay, so they had given us a block of mass 22 kilograms, okay, which is placed on a rough inclined surface. Now please note, the moment they tell us it's a rough surface, then we know that there is frictional force, right? And they say it's connected to a 15 kg block that hangs vertically by means of a light inextensible string. Now, why is that important to say it's a light inextensible string? So first of all, light simply means that we will not add the mass of the string in the equation, right? And then secondly, it's inextensible. It means that the tension on the one side of the string should be equal to the tension on the other side. Okay, so in this case, so the acceleration of the system would be the same, because it's not like it's elastic, right? And it's a frictionless pulley that we normally use, because it's actually the tension should be the same on either side of the pulley, right? Okay, so we're saying that the string is passing over a frictionless pulley, as I did indicate, as shown in the diagram. Okay, so they say when the inclined surface is at an angle of theta, okay, to the horizontal, the 15 kilogram block moves downwards. Okay, so we know this block therefore moves downwards. Okay, and they say at a constant velocity. Now please remember, ladies and gents, so the moment they tell us that it's at a constant velocity, of course we haven't gotten to the part where we are answering the questions. What it simply says to us is that acceleration of the system is zero. Please remember that there's no change in velocity, right? What is acceleration? It's change in velocity divided by the change in time. So in this case, when they say it's constant velocity, the velocity stays the same, so the acceleration is zero. Right, now they said state Newton's second law of motion in words. Of course, I know that you can mention that. It says, if a resultant force acts on a body, the body will accelerate in the direction of the resultant force, and that acceleration is directly proportional to the resultant force and inversely proportional to the mass of the object, right? However, you can also mention it in another way, which simply says, okay, that acceleration is equal to the rate of change of the body's momentum. Okay, that's the simplest way of actually mentioning Newton's second law. All right, now they say draw a labeled free body diagram of all forces acting on the 22 kg block. Now let's talk about that 22 kg block. So what are the forces that are acting on it? Okay, so if this guy is going down, what is it doing to the 22 kg block? Because the system is connected, as this one goes down, it's pulling the 22 kg in that direction. So 22 kg would actually go up. Okay, so it's being pulled by the tension there. So I know that would be the tension. okay, acting parallel to the incline. And then I also have frictional force that opposes motion, right? So this would be the frictional force, okay? And what other force do we have? We know we've got gravitational force over here. So you can say that's gravitational force. So that's a force of gravity, or you can simply say the weight. Okay, please note that the weight is vertically downwards. Okay, so it actually goes vertically downwards. But what do we also have? We also have the normal force. Note the normal force. Okay, it's perpendicular. Note that they're not making a straight line with gravitational force, right? That's the normal force there. And by the way, you can also draw the free body diagram in another way, which is, in this case, you could, of course, that's the normal force. I'm not going to write them out in full, okay? But please remember, if you don't write the words out in full, please just make sure if you use acronyms, just explain what those acronyms are. So for instance, if you wrote that as FG, you must say FG dash force of gravity, okay? So there's my frictional force. I'm going to say this is Fk. But instead of using my gravitational force there, I would rather use the components of gravity. So I'm just going to draw them in another color. Okay, so I'm going to have that there, note. So this is going to be Fg perpendicular, okay, as well as in this case, remember that we said it's always going down the incline. So this is going to be Fg parallel. Note that now the Fg parallel is parallel to the incline, and Fg perpendicular is now perpendicular to the incline. So in this case, it now makes a straight line with the normal force. Okay, right. So keep that in mind. Okay, so they say a constant frictional force of 43.83. Okay, so they told us that there's a frictional force of okay, sorry, I'm just going to adjust that a little bit. So that's going to be 43.86 newtons. Okay, they say it acts on the 22 kilogram block. Calculate the magnitude of the angle that will keep the system moving at a constant velocity. Okay, so in this case, what are we going to do? All right, so let's look at all the forces that are acting on that force over there. Okay, on rather the 22 kg block over there, right? If you asked me, so in this case, I would have a little bit of a challenge having to use the forces that are in the vertical, that are parallel. Why? Because I don't know the tension. You know, there are just too many variables. Yes, I don't know the tension, but well, I would have the frictional force. But in this case, I would also not know FG parallel, and the reason for that is that that angle is not given there. Okay, so in this case, let me rather use the frictional force. Remember that friction is equal to the coefficient of friction. Okay, we were given you know, the coefficient. No, we're not actually given the coefficient of friction there. Okay, multiplied by the normal force. Okay, yeah, so we're not given the coefficient of friction, so yeah, no, my idea would not work. Okay, so let's go back to that. Okay, so I would know what the tension is. In fact, yes, I would know what the tension is, because remember that the net force for this over here is also 0, right? So the sum of forces on the 15 kg block, okay, would be 0. So what are the forces that are acting on the 15 kg block? It's going to be the force of gravity as well as the tension. So if my net force on this 15 kg block is 0, so it means that the tension would now be equal to gravitational force, right? So then I would say, now let's look at the forces that are acting on the parallel, right? for the 22 kg block, I'm going to say, well, I know F net is equal to MA. All right, so what is my F net? I'm going to look at forces that are moving parallel. So that's going to be tension. I'm going to take the direction of motion as positive, by the way. Okay, so that's tension minus frictional force minus the parallel component of gravity, and this is equal to MA, right? Now I know that this is equal to, my acceleration is 0, so actually that's all equal to 0. So, but because I already know my tension from that, now remember we said force of gravity here would be equal to the tension over there, and we know we've got a frictionless pulley, so it would be equal to that tension over there. So in this case, can I get the force of gravity for the 15 kg? This would be 15 multiplied by 9.8. Okay, let's do that quickly. So that's going to be 15 times 9.8. So that would be 147. So it means that tension there would be 147. It means the tension there would also be 147. So that's tension minus the friction, which is 43.86, minus, now please, I want you to note, how do we get FG parallel? I'm sure if you haven't watched our videos on Newton's laws, please just do so there. How do we get FG parallel? We always say it's mg, the sine of theta, and theta would be the angle of elevation, isn't it? So this is going to be the mass, which is 22, times 9.8, the sine of angle theta, and please remember this is equal to 0. Okay, so of course all that's left for us to do some mathematical magic rather. All right, so that's 147 minus 43.86. okay, so this is going to give us 103.14, which is so 22 times 9.8, that would be 215. Now note, I'm taking this to the other side, so I've got 215.6, the sine of angle theta, so I can divide both sides by 215. Okay, all right, so I've got 103 on the other side, so that's divide by 215.6. okay, so I can cancel that out, and so we can simply say theta is equals to the arc sine of that. So let's say arc sine of 103.14 divided by 215.6. okay, and I get an angle of 28.58. So the angle there would be 28.58 degrees. All right, so that would be the angle of elevation of our incline. Okay, right. And then they actually just changed something about that question there. I hope you were okay with that. All right, so in the next question, they say to us, explain why the kinetic frictional force remains the same even though the system accelerates. Now, why would friction remain the same? Because remember, what is friction dependent on? It's dependent on the normal force, which in this case, the mass of the object doesn't change, so the normal force doesn't change, and also the coefficient of friction, which is in a sense the roughness of the surface, right? So in this case, we say that those would remain constant, so therefore friction would remain constant. Okay, right, now they change something about this question. All right, and I'm going to just do that in the next section. Okay, so they say to us, a force of 172 newtons is now applied on the 22 kg block. Okay, and the system and the system of blocks accelerates down the slope. So they take the 22 kg block, all right, and they apply a force, okay. So the kinetic frictional force acting on the 22 kg block while it accelerates downwards remains the same. So now they are applying a force of 172 newtons, okay, which is being applied on the 22 kg block. Now, please, I want you to note, so in this case, I'm going to say it means there's 172 newtons over there, and that's the applied force. But what does it do? We still have the tension over there. Okay, sorry, that's our pulley, and we still have that 15 kg block. Okay, so they tell us that the system is now going to accelerate in that direction. Okay, so let's talk about that quickly. Right, so we've already found out that the angle there is 28.58, so we're going to use that angle this time around. Okay, they wanted us to determine the acceleration. Okay, right. And so what we're going to do is look at the forces. Okay, in fact, by the way, you can take that entire system as just one particular system. Okay, so how you do that is that you take the sum of the masses and you take the external forces. All right, so in this case, two ways that you can do it. Okay, you can say, well, I can take the let's say for 22 kg block. All right, this is the safer method, right? I will say, well, what's my free body diagram? You remember that we had now we're going to have the force applied. Okay, I'm going to say FA, which is 172 newtons. Okay, we've got, now please note, because it's going down the incline, it means that frictional force would be on the other side. So we've got friction over there, but we also have tension that now acts there. So that's going to be friction. Okay, that's going to be the force of the tension. Okay, the tension on the string. But you also have the other forces, which was a normal force, which was a gravity perpendicular, as well as gravity parallel. Okay, so I know what my FG parallel value, remember it always goes down the incline. Okay, right, please don't forget that. So now I'm going to simply say, what are the forces? Let's take the sum of them. Okay, we're going to say F net is equal to MA. Now note, I'm going to say, well, it's going to be the force applied plus FG parallel. Okay, they're acting together in the same direction, minus kinetic friction, minus the tension. And this now, please remember, it's now accelerating, and that's what we want to find. We want to find the acceleration of the system. So this is equal to MA. Okay, so let's try and substitute what we know. Okay, so that is going to be 172. Okay, minus our FG parallel, remember that's mg sine theta, so that's going to be 22 times 9.8, the sine of our angle theta, which is 28.58. okay, minus, remember they did indicate to us that our friction remains the same, and our frictional force value was given as 43.86. So that's minus 43.86, okay, minus that tension is equal to, what's the mass? It's 22A, okay. Whoa, that looks like a massive equation, but of course we can simplify it, right? Let's try to clean it up before we can proceed. Yeah, okay, let's in fact, shoo, I almost made a mistake there. Remember, we are adding this one, okay? So when you calculate that, I get 231.28 minus tension, and this is equal to my mass times acceleration, so that's 22a. Now, then we can quickly jump to the other one, which is the 15 kg block. All right, the forces acting on it, that's going to be the tension, and that's going to be gravitational force. Okay, and we had already calculated it. That was 15 times 9.8. Okay, 9.8, and it was 147. Okay, newtons. So now we can say, well, for okay, sorry about that. So for the 15 kg block, okay, so we know that for the 15 kg block, it means that F net is equal to MA. Okay, so that's the sum of forces in the vertical, so it's going to be the tension. Okay, I'm going to take upwards as positive. So in this case, by the way, I forgot to mention, remember, we always take direction of motion as positive. So in this case, it's going down, and this one is going up. So this one would be positive going that way. So I'll say tension minus my force of gravity is equal to MA. Remember that acceleration remains the same, right? So that's tension, which we don't know, minus gravitational force, which is 147, is equal to the mass is 15, and we want the acceleration. And by the way, we could have called this equation 1, and let's call that equation 2. And what I simply do, ladies and gents, is that I simply take equation 1 plus equation 2, and if we sum those up, we'll have 231.28, sorry about that, minus tension, plus what's on the left hand side of this equation, that's t minus 147, is equal to 22 plus 15a, 22a plus 15a, okay, and that will be 37a. Look at what that does. Those tensions cancel out, okay, so I get a value of so that's 231.28, okay, and we divide that by 37, and I get a value of 2.28. So our acceleration is going to be 2.28 meters per second squared. Now, of course, some of you are probably thinking, oh, Seb, but you could have taken this just as one system. Absolutely, I agree with that. What I've found normally is that for people who usually take on that approach, and there's absolutely nothing wrong with it, please just remember to include that frictional force, okay? Because then they would say, yeah, we take it as one system, and then they would say, well, it's that force that's applied there minus the gravitational force, right? And they forget to actually subtract that frictional force there, right? And you can now add the masses and get that acceleration, okay? Right, so I'm not going to waste any more time on that one. You can do that the other way. Okay, you'll still get to the same answer for as long as you include that frictional force. And I hope, ladies and gents, that has been extremely helpful, right? And please just don't forget to subscribe, eh? And remember, if you need help, just shout info@mlungisinkosi.co.za. See you guys next time. Sharp, sharp.